All right, concept 6b is about inductive and deductive reasoning. Our objective here is to use deductive reasoning to draw conclusions. So we're going to start off with quite a bit of vocabulary here, and then we'll do some examples at the bottom. So our first little bit of definitions is inductive reasoning. Inductive reasoning is based on observation and or patterns. I'm just going to put a slash there. Okay, deductive reasoning is based on facts. You could also say definitions or properties or anything along those lines, but hard facts. Okay, the next part is about conditional statements. So conditional statements have an if-then part of them. So the if part of the conditional is called the hypothesis. You may have heard these terms in your science classes. The then part of the conditional is called the conclusion. So if this, then this is going to happen. Okay, so here's an example. If we're testing the validity of a conditional statement, we're asking, is the conditional below true or false? So if Jan lives in Missouri, then she lives in Liberty. Well, if she lives in Missouri, she could also live in Kearney, or she could live in Smithville. She doesn't have to live in Liberty. Liberty isn't the only city in the state of Missouri. So this conditional is actually false because Jan could live in another city. So there isn't just Liberty in Missouri, there's other cities. Okay, a counterexample. If we are wanting a counterexample, this is a statement that proves a conditional is false. Okay, so we're saying, well, Jan could live in Kearney. That is a counterexample. Okay, a converse is when we switch the hypothesis and the conclusion. So we're saying if the hypothesis, or if the conclusion, then the hypothesis. So an example of that is if Jan lives in Liberty, then she lives in Missouri. Which, if there was only one city, Liberty, which we live in Missouri, this would be true. However, there are other cities named Liberty in other states. So it doesn't specify that it's the Liberty in Missouri. It could have been the Liberty in another state. So this converse is also false because there are other states with a city named Liberty. So that is a little fun fact. If you didn't know there was another state with a city named Liberty, if you want to look it up and figure out what state it is, go for it. Okay, next example. Circle the hypothesis and underline the conclusion of the conditional below. If G is on ray AB, then G is also on ray BA. So they want us to circle the hypothesis. So remember, the hypothesis is the if part. So we're circling the if part. I'm going to make my circle prettier. Let's see. Oh, maybe I didn't connect it. Okay, it's not going pretty. Okay. And then they want to underline the conclusion. So then is the conclusion part. This conditional is false because, let's say, if G is on ray AB, then G is also on ray BA. So let's say I have, here's ray AB, right? And so G is on, actually let me make this longer. Here's ray A B. Okay, if G is on ray AB, let's say G is here. Okay, if G is supposed to be on BA, that would start, let me change my color, that would start on B and go towards A. In this case, G is not on that ray. So G does not have to be on ray BA if it's on ray AB. So that is false due to that diagram. I'm just going to draw a little picture over to that. Okay, a converse, remember if we go back up to the converse, that is here where we are switching the hypothesis and the conclusion. So we are now going to say if G is on BA, then now we're going to put our hypotenuse, or not our hypotenuse, our hypothesis, then G is on ray AB. So we took our conclusion and we put it first, and then we took our hypothesis and we put it second. So we just flip the order of those. All right, last example here. We are writing a conditional that is false, but we want its converse to be true. So we want the original conditional to be false, but then when we switch the hypothesis and the conclusion, we want to make it true. So let's think. I'm going to use quadrilateral and a rectangle. So if, because I know quadrilateral is a very general term, so if a figure is a quadrilateral, then it is a rectangle, which is not the case because we can have a four-sided figure that's not a rectangle. For example, it could be a kite, it could be a rhombus, it could be a square, so it doesn't have to be a rectangle. However, if we switch this and we say if a figure is a rectangle, then it is a quadrilateral. That is true because every rectangle has four sides, which is the characteristic of a quadrilateral. So that is true, and our regular conditional was false. All right, that is all for Concept 6B. Go ahead and go to the next video for the Concept 6 teacher talk.